So now that we have derived the unit circle, let's talk about the 6 trig functions and then how do we use the unit circle. So when we talk about the unit circle, we're talking about the thing that we just derived, and we're going to talk about P being a point on the unit circle. The sine function is going to be just the y-coordinate. Cosine function is going to be the x-coordinate. Tangent function is going to be y divided by x. And then we've got some reciprocal identities. We've got cosecant, secant, and cotangent. So really everything goes back to what if it's not on the unit circle? And this is what I want you to really know. These are the definitions that you really need to focus on. What if it's not on the unit circle? Because it can be on any circle. The sine is going to be the y-coordinate divided by the radius. Now, for the unit circle, the radius is 1. So for the unit circle, it's just going to be y over 1, which is just going to be the y-coordinate. That's where the definition from the previous page actually came from. Okay, everything's based around these definitions. Cosine is going to be x divided by r, which is just going to be x divided by 1 if it's on the unit circle, which is just going to be x. And then tangent's going to be y over x, and then so on. So let's look at a few examples. We've got this point square root of 3 over 2 1/2, and they're asking us to find the exact values for the 6 trig functions. So we're looking first for sine of theta. Sine of theta is going to be y divided by r. Well, we've got to figure out what the radius is first. So we're going to look at square root of 3 over 2 1/2. Square root of 3 over 2 and then 1/2. Here's our triangle. Okay, notice that x and y are both positive. That's why I put this in the first quadrant. I've got to figure out what the radius is. So to find the radius, we're going to use that Pythagorean theorem, right? X squared plus y squared is equal to r squared. So I'm going to use square root of 3 over 2 squared plus 1/2 squared, and that's going to be equal to r squared. So this is going to be 3 over 4 plus 1 over 4. That's going to be 1. And when I take the square root, I'm going to get 1. The radius is always going to be a positive number because we're talking about a distance, how long something is, right? And we're talking about the radius of a circle. So for 13, my sine is going to be 1/2 divided by 1, which is 1/2. The cosine function, cosine of theta, is x over r. So I'm going to get square root of 3 over 2 divided by 1, which is square root of 3 over 2. Tangent is y over r. So I'm going to have 1/2 divided by square root of 3 over 2. And remember, when you divide, you keep change flip. Oops. So I'm going to get 1 over square root of 3, but we have to rationalize. We're not going to leave square roots in the denominator in this class. So we're going to end up with square root of 3 over 3. And then we need to find the other trig functions. So let's find secant. So secant is actually the same thing as 1 over cosine. And notice that the relationship there is really just flipping that fraction. It's the radius divided by x. So we're going to get 2 over square root of 3, which is 2 square root of 3 over 3. Let's find cosecant. Cosecant is r divided by y. Okay, notice the relationship here. It's the same thing as 1 over the sine. So my radius is 1. My y value is 1/2. 1 divided by 1/2 is 2. And then I need to find the tangent of theta. Sorry, I found tangent. I need to find cotangent. Okay, look at your relationship here. Cotangent is the same thing as 1 over the tangent. Okay, that's why it's equal to x over y. So square root of 3 over 2 divided by 1/2. So square root of 3 over 2 times 2 over 1, which is just going to be square root of 3. All right, so let's do another one. I'm going to go through and erase that. And suppose we were doing maybe number 20. Okay, number 20 is not on the unit circle. It's not like the last one that we did. We know that this guy was on the unit circle, square root of 3 over 2, 1/2, because we derived the unit circle in the previous video. So this is where you may want to pause the video, try to find the value for the 6 trig functions, and then come back and check your answer. So let's start with sine. So sine of theta equals y over r. So my y is negative 2/3, and I'm dividing it by negative square root of 5 over 3. So I'm just going to do some simplifying here. So I've got negative 2 over 3 times 3 over negative square root of 5. So I'm going to have 2 over square root of 5. Multiply the top and bottom by square root of 5. And here's our final answer. So if we do cosine of theta, cosine is x over... Oh, hold on 1 minute. I actually goofed up. We've got to find the radius first, guys. So let's do that. Let's draw our picture. Let's find tangent. So where is this guy located? This guy's located over here. This is negative square root of 5 over 3. This is negative 2 over 3. I've got to figure out r. Okay, that's the radius. So I'm using x squared plus y squared is equal to r squared again. That's your Pythagorean theorem. So negative square root of 5 over 3 squared plus negative 2 over 3 squared is equal to r squared. So this is going to be 5 over 9 plus 4 over 9. And that's going to be equal to r squared. So it looks like r is going to be 1 again. Okay, well that's nice, because this is going to make these really easy for us. So this is going to end up being y over r, so negative 2/3. Cosine of theta is x over r. X over r is negative square root of 5 over 3 divided by 1, which is negative square root of 5 over 3. And then tangent of theta, which is what we accidentally found a minute ago, was y over x. Maybe it was cotangent, I forget now. Negative 2 square, oops. Negative 2 over 3 times negative 3 over square root of 5. Negative times a negative is going to give us a positive. So we're going to have 2 square root of 5 over 3. So now we've got those. Let's find the other ones. Sine cosecant of theta is going to be 1 over sine of theta. So I can just do 1 over this. which is negative 3/2. Secant of theta is 1 over cosine of theta, which is going to be 1 divided by negative square root of 5 over 3. So negative 3 over square root of 5, or negative 3 square root of 5 over 5. And then let's find cotangent. Cotangent is 1 over tangent. Or we could do x over y. Either one will get us the same place. So we have 1 divided by 2 square root of 5 over 3. So we're going to have 3 over 2 square root of 5 multiplied by square root of 5 in the top and bottom. So we're going to have 3 square root of 5 over All right, hold on, guys. I just saw a mistake. Let's go back to the tangent here. So this is right, but I don't know why I put a 3 here. I think I'm just writing messy, and it's hard for me to see what I'm doing. So this is going to be 2 square root of 5 over 5. So now we need to go back and we need to fix this cotangent because we based it on a false answer there. So we have 1 over tangent, which is going to be 1 over 2 square root of 5 over 5. So now we're going to have 5 over 2 square root of 5. And if we multiply by square root of 5 over square root of 5, because we need to rationalize, right? We have 5 square root of 5 over 2 times 5, which is 10. And you can see that outside 5 cancels with this 5. So we get square root of 5 over 2. So make sure you correct those mistakes when you're writing your notes. Sorry about that. So we have found all 6 trig functions for those points, and those points were on the unit circle. So let's do a few more. So we've got circle here where we want to find exact values, and I'm going to look at these 3. These are going to go back to our unit circle. In that first one, we want to find cosine of negative 3 pi over 2. So I'm going to go back to my unit circle up here. Negative 3 pi over 2 is going to go backwards around that unit circle. So we're going to go backwards to here. And this is the ordered pair that we're going to use to figure that out. So we're looking for cosine. And the cosine of negative 3 pi over 2 is going to be that x-coordinate, which is 0. (28) is looking at the sine of negative 3 pi. So we're going back to that unit circle. So we're going backwards around the circle, right? So we're going to go, here's negative pi, negative 2 pi, negative 3 pi means we're using that ordered pair. And we are looking for the sine there. The sine is the y-coordinate, and the y-coordinate is going to be 0. And then in 29, we're looking for secant. So remember, the secant is the same thing as 1 over cosine. So we need to figure out the cosine of negative pi. So we're going to go back here. Negative pi would be this. The cosine is going to be the x-coordinate on the unit circle, which is going to be a negative 1. And our answer is going to be negative 1 for that.